Hi, welcome to another video on differential equations. And now this is probably one of the most important chapters in the differential equations book because it's Laplace transformation. Laplace transformation is a beautiful transformation because you could use this on any differential equation of higher order, excuse me. And this is basically the end of the course. It's usually what professors look forward to teaching. So let's get into it. Laplace transformation is basically a type of integration. The purpose of using Laplace transformation is to transform a differential equation into an algebraic equation. It's much more simpler to handle and manage. Any applications for Laplace transformation? Yeah, of course. We could use this in circuits, usually seen in mechanical systems. And basically there's two types of Laplace transformations. There's the linear and, you could use this transformation on two types, which is the linear and IVP problems. And most importantly, Laplace preserves addition and scalar multiplication. All right. And for Laplace, there are some transformations that you have to memorize. So first we'll start off with the Laplace of t to the n power. All right, so, the most important one. We can write that up here. All right, so what I'm writing down are some basic Laplace transformations, and you'll come in contact with most of these, and you'll see how these operate. And let's talk about a few right now, because right now I'm just writing a bunch of letters. So I'm writing an L and A's and S's. Well, the S is just a parameter. So we'll have a variable t, and once we Laplace that, it's going to turn into an S. So it's just using a different parameter, just changing a variable. All right, so I hope that you've seen some of these transformations already in your class. All right, so these are the basic ones. I think there's 7, if I count correctly. So it's 4, 5, 6, 7. Yep. Okay, so this first one is Laplace. These are the curly brackets. I don't feel like writing out that little curly bracket. I don't even know how to draw it, I guess. But yeah, these are curly brackets. These aren't parentheses. Okay. The Laplace of 1 is equal to 1 over s. The Laplace of exponential function is this. So we'll be using these when we're solving, and how it's usually mentioned, it's Laplacing something. It's informal, but it's how I refer to it as. But yeah, let's get to some problems. Okay, so we'll start off with this one. Okay, so we have a function f of t. A function f of t is equal to -4t squared plus 16t plus 9. All right, so what we're going to do is we're going to Laplace the function. Okay? And so basically we have this -4 on the outside of the plus, because we're only Laplacing that t, right? And this is, we could think about it like that. All right? Okay, so now we have, I'll write out the steps. Okay, so for this one, for t squared, the Laplace of that was going to be 2 factorial over s to the third power. The Laplace of t is going to be 1 over s squared. And the Laplace of 1 is simply going to be 1 over s. All right, and so we just multiply that out, and we get -8 over s cubed plus 16s squared plus 9 over s. And that is the Laplace of the function f of t. And so that's basically all it is. We just Laplaced our first function. And notice how we're going from a t variable to our function having s's, right? Okay, great. Let's see another one. So another problem we have e to the t minus e to the -t quantity squared. Okay, so we want to find the Laplace of the function. Well, this is our function t. Great. So if we Laplace the function, well, if it's definitely smart to factor this out. I mean, FOIL it out, right? And if you don't know why, it'll be clear, because now you have the Laplace of e to the 2t squared, oops, minus 2 plus a 1 plus the Laplace of e to the -2t. All right, and so that's way easier to Laplace. It's way easier to see as well, because before it was just that. All right, usually when you have something like this, you want to FOIL it out and expand it, okay? Well, now that's just going to give you 1 over s minus 2 minus 2 over s plus 1 over s plus 2. And that is our Laplace of the function f of t. Okay, so if we look back at our transformations, whatever this power is, this is our a, t, and this was s minus a. So we just took that 2 there. And yeah, you just have to become familiar with the transformations. And once you know them, it'll be easier and faster to recognize what the transformation is. Great. Let's move on. All right, so this one's a good one. We have the function of t equal to cosine 5t plus sine 2t. Okay, great. So let's Laplace the function. And the Laplace of cosine 5t plus the Laplace of sine 2t. Okay, well, that's going to be equal to s over s squared plus 25 plus 2 over s squared plus 4. And now if we look back, at our transformations, this was k. This was a kt, right? So it was a kt, that meant that this one was k squared. So if this was a k, we have to square it, and that's where the 25 comes from. Same thing here. This is our k, and now it's k squared, which is 4. Okay? Great, that one's pretty fast. And most of these problems will seem fast because they are quick and easy. Because this is a quicker way to solve these differential equations. Okay, so we could talk about this one. Now this problem brings back memories of trigonometry. So I hope you don't have nightmares about trig. I hope you're going to be fine. Okay, so one thing we have to think back is trig. Okay, so in trig, we have this formula, sine theta times sine phi equal to cosine of theta minus phi minus cosine of theta plus phi, or phi or phi, whatever you prefer. Tomato, tomato, potato, potato. All right, so this was one of our formulas for that. Okay, and that looks pretty similar to that. So what we're going to do is we're going to put it into this format. Okay, so now we have 1/2 cosine t minus 2t minus cosine of t plus 2t, and that's times 1/2. All right, so if we do the computation inside the argument, and don't argue about it, it's the argument. We have cosine minus t minus cosine 3t, right? That's times 1/2. Then we could go and Laplace our function now. now that we've made it a little easier to see in terms of this, because you couldn't Laplace this because it's multiplication. So you'd have to make it into subtraction or addition, and that's key. So remember, you can't Laplace a function that's being multiplied because it doesn't preserve that. All right, so we have cosine. And if we think back to trig or a pre-calculus course, this is even function, so it gets rid of that negative. Great, one less negative to think about. Okay, so then we get 1/2 times s over s squared plus 1 minus s over s squared plus 9. And that is our Laplace of the function t. Great. Wow. Using Laplace is so easy. And if it's not easy, it's definitely fast. Great. So that is essentially the Laplace transformation. Thank you.